Okay, so today we're learning about sketching the graph of polynomials. In Algebra 1, you learned about the zero product property. And the zero product property told us that when a function was equal to 0, each factor could be set equal to 0. And if you solve for each factor, you'll be able to solve for its x-intercepts, which are also known as the zeros of the function. So I want to sketch the graph of x times x plus 2 times x minus 3. So what I'm going to do is I'm going to set the equation equal to 0. So I'm going to say 0 equals x times, skipped ahead a little there, sorry, x times x plus 2 times x minus 3. So now I'm going to set each factor equal to 0. So I'm going to say x equals 0. And sorry about the writing being a little messy. Forgot the tablet at school, so I'm having to use my finger at home. So now I have, that one's done. That's already solved. I have x plus 2 equals 0. And so to solve that, I subtract 2. And so x equals negative 2. So that's another x-intercept. And so these x-intercepts are going to be some critical points on our graph. They're going to be critical points on our graphs. They're very important. They show us where it crosses the x-axis. And then my last one, x minus 3, I set x minus 3 equal to 0. And so then I add 3 and x equals 3. All right, so now these three numbers, 3, 0, and negative 2, they are my x-intercepts. Now remember, the domain of all polynomials, okay, all polynomials have a domain of all real numbers. So if you remember back to your Explore in 5.2, the domain of every single polynomial you did was all real numbers, negative infinity to infinity. So we're actually going to break up this domain into smaller pieces, because each time it crosses the x-axis, it could change from positive to negative or negative to positive. And by determining what sign it is in each of those intervals, we'll be able to determine what the graph should look like. So the way I create my intervals is I start on the left at negative infinity. So notice I start at negative infinity. So all your intervals for polynomials will start from negative infinity. And then I go from negative infinity to my smallest x-intercept. Then I go from that x-intercept to the next smallest x-intercept. I go from that one to the next smallest, or in this case, my biggest. And then my biggest x-intercept always connects with infinity. Always connects with infinity. All right. So we're going to fill in this table based upon that information. So notice I have negative 2, which matches my x-intercept over here. We have 0, which matches this x-intercept. And I have 3, which matches this x-intercept. So what we want to do on these intervals is you want to pick a test value in your interval. A test value is any value inside the interval that is inside it. It can't be one of the endpoints, but any number that's in between those values, it works. So for example, for this first interval, I chose negative 3, because negative 3 is a nice value. It's not too big, and I can plug it in. And so then I want to plug it into each of my factors. So if I plug negative 3 into x, well, that's a negative number. If I plug negative 3 into x plus 2, I get negative 3 plus 2 is negative 1. That's negative. If I plug it into negative 3 minus 3, that's negative 6. That's negative. And so then, remember, factors are multiplied together. So I have a negative times a negative, which is a positive, times another negative is a negative. Since the entire sign there is negative, I know that my graph has to be below the x-axis in that interval. So I need to fill out the rest of this table, and then I'll be able to sketch my picture. So now on the interval negative 2 to 0, -1 would be a really friendly value to pick. So if I plug it into x, that's negative. If I plug it into x plus 2, -1 plus 2 is 1. That's positive. And if I plug it into -1 minus 3, that's -4. That's negative. So I have a negative times a positive times a negative. So two negatives make a positive times another negative is a positive. So the sign of my whole function is positive on this interval. Okay, then I showed an example here between 0 and 3. I picked 1, but you could have picked 2. Any friendly number works. So when you plug it into x, you get 1, which is positive. 1 plus 2 is positive. 1 minus 3 is -2, negative. So my sign of f of x is negative. Between 3 and infinity, I'm just going to show an example that I don't have to pick a number right next to my value. So maybe on this one I'll pick 10. So if I plug into x, the sign of x is positive because 10 is positive. 10 plus 2 is 12, that's positive. And 10 minus 3, that's 7, that's positive. So 3 positives, when they're multiplied, is another positive. So now we're going to sketch the picture. So the first thing you're going to do is plot your x-intercepts. So I have an x-intercept at -2. I have an x-intercept at 0. I have an x-intercept at 1. Sorry, no I don't. I have an x-intercept at 3. And then that's it. Those are my 3 x-intercepts. So you go back to your intervals up top. You can see my intercepts are -2, 0, 3, and infinity. These are not your test values. Now in that area of my test values, that just tells me if my graph is above or below the x-axis. So in this interval over here, that interval is -2 to negative infinity to -2. This interval that I just marked is negative infinity to -2. So I know to the left of my point there, the left of my intercept, I need to be below the axis. So my curve goes below the axis. All right, so somehow it's below the axis. So I'm going to go ahead and erase that one mark. And I just know that somehow my graph is going to have to be below the axis here. It doesn't really matter how you make it, but I do know it needs to be below. Okay, and I'm just going to give myself a little space from the point right now because I don't know if it curves through the point or if it goes above through the point. Maybe it's tangent. So then I look at my next interval. My next interval is -2 to 0. That's this interval. That's that interval. Now on that interval, we found that it was positive. It was positive. So that means I do cross through the point of -2. And now I've got a little more of a sketch. It went through. I don't care how far your hill goes up. Okay, it just needs to go through and keep it a smooth curve. Then between 0 and 3, the interval was negative again. So if you look there, it became negative. So I'm going to go below my axis until my next x-intercept. And then after my next x-intercept, it became positive again. And then I just throw on arrows on both ends. So there's my sketch of the graph of x times x plus 2 times x minus 3. And again, there are variations, okay? There are variations. I'm going to use the color blue to show us another variation. So maybe I didn't know what it did off here, so maybe I had it a little shallower, maybe I had to go up higher, then maybe I had to go deeper, like that. Okay, so your graph, your hills and valleys may be different. What's important and how it relates is that the positive areas and the negative areas are the same, and you go through the correct x-intercepts. So let's do another one. All right, now I have the graph of negative x minus 4 times x minus 1 times x plus 1 times x plus 2. You want to identify the zeros of the graph. Now guys, the zeros are the things that make each of these factors 0. So some of you might start noticing a pattern and be able to simplify. Now that negative is a -1. That's really a -1 up there. And can -1 ever equal 0? No, it cannot. So that will never affect my sign. All right, so now I get x minus 4 equals 0. And when I say, so negative 1 equals 0, it'll affect my final multiplication only, but it won't affect my actual 0 values. So what makes x minus 4 0? When x equals 4. What makes x minus 1 0? When x equals 1. What makes x plus 1 0? When x equals negative 1. What makes x plus 2 0? When x equals negative 2. So again, I don't expect you to necessarily be showing all your steps because that was a skill you learned in Algebra 1. So now I've got to make my intervals on my table. I've got to make my intervals on my table. So my smallest intercept was negative 2. My next smallest intercept is negative 1. So I'm going to go ahead and I'm going to go from negative 2, and it's going to be less than x, and it's going to be less than negative 1. Then we're going to go from negative 1, and it's going to be less than x. Sorry, my lesson signs are not coming out fabulously. And that's going to be less than, let me see what my, looks like positive 1. It's going to be less than positive 1. Then I'm going to go from positive 1 is less than x, is less than, and my next x-intercept is 4. And then from 4 goes to infinity. So now I want to pick a test value in each interval. So notice sometimes I will have to pick fractions. So for example, in this interval, I do have to pick some fraction. So I'm going to go ahead and do negative 1.5. Okay, in this one, 0 is really nice. In this one, I'll go ahead and go with 2. And then I already showed you what I did with the other 2's. All right, now if you notice on our table, I have to list each factor. And keep in mind that negative 1 is one of my factors. So the sign of negative 1 will always be negative. So notice I have that negative going the whole way across because it's always negative. Now I have to figure out what is the sign of x minus 4. So when I plug negative 1.5 in, that's negative. Negative 1.5 minus 1, that's negative 2.5. Negative 1.5 plus 1, that's negative 0.5. And negative 1.5 plus 2 is positive 0.5. That's positive. So a negative times a negative is a positive. Times another negative is negative. Times another negative is positive. Times a positive is positive. So all these signs together make a positive. So notice I don't care what the exact values are. All I care about is their signs. This is called a sign chart. Okay, now I plug in 0. 0 minus 4 is negative. 0 minus 1 is negative. 0 plus 1 is positive. And 0 plus 2 is positive. Since there's 3 negatives, my final answer will be negative. Okay, I plug in 2. 2 minus 4 is negative. 2 minus 1 is positive. 2 plus 1 is positive. 2 plus 2 is positive. Since I have 2 negatives, that's a positive. And then if we look at the very final part of our chart, okay, if you look at our final part, we see we get 1 negative and all positive, so the 1 negative makes a negative. So my graph goes from being below to above to below to above to below. So notice each time it's going to change. At each x-intercept, it's changing signs. So now I'm going to go plot my x-intercepts. So I plot them at negative 2. I plot them at negative 1. I plot it at 1 and 4. And so to the left of negative 2, when it's less than negative 2, it's negative. So I'm going to go off this way. And then between negative 2 and negative 1, it's positive, so it's going to be up here somewhere. And then between negative 1 and 1, it's negative, so it's going to be down here somewhere. Between 1 and 4, it's positive, so it's going to come up here. And between 4 and infinity, it's negative. So there we go. Notice both my ends are facing down. In this, we had 4 x's. This was x to the 4th. So it's an even power. And so both ends are following the same behavior. And they're going down because of that negative in front. All right, let's do plus 2 together, and then the last 3 you guys are responsible for. So now I have x squared times x plus 3. I have x squared times x plus 3. So we're going to go ahead and identify the zeros of the graph. And so x squared equals 0. Well, you can take the square root, but the square root of 0 is 0. So this happens when x equals 0. When does x plus 3 equal 0? When x equals negative 3. That is a horrible 3, but you guys get the picture. All right, so then you need to make your intervals. And as you get further on, you're going to have to make these intervals on your own. So notice my interval starts at negative infinity. My interval starts at negative infinity. And then it goes to my smaller intercept of negative 3. Now from negative 3, I'm going to go ahead and have to go to 0. So I'm going to go from negative 3. For some reason, I have a really hard time with 3's on here. Less than x is less than 0. And then from 0, we go to infinity. You need to pick a test value in each interval. So there I picked negative 5, and here I like negative 1, and over here 1 is really nice. I just like to pick smaller values. They're a little friendlier. So the sign of x squared, well, x squared, when you square a negative, it's always going to be positive. So negative 5 squared is positive. Negative 1 squared is positive. And 1 squared is positive. So now I see how they are with x plus 3. Negative 5 plus 3 is negative 2, so it's negative. Negative 1 plus 3 is 2, which is positive. And 1 plus 3 is 4, which is positive. So notice I have 2 positives, which is a positive. I have 2 positives, which is a positive. So this time I have an interval where in a row, that same interval will actually keep the same sign. So since the sign's not going to change, I won't end up crossing through that x-intercept. So you'll see how this looks in the picture. So same process. I'm going to go ahead and I'm going to plot each of my intercepts. So I have negative 3, I have 0, and that's it. So when it's to the left of negative 3, it's negative. Now when it's at 0, when it's between negative 3 and 0, it's positive. But then it's positive again over here. So the only thing I'm going to do, so I made this positive and then positive again. The only thing I'm going to do, since this is a sketch, I'm just going to go ahead and sketch in to smooth it out. So since you are a sketch, you can erase a little bit or just go ahead and curve it to make sure that that looks like a curve. Oops. Okay, and so then it touches, but it goes up again. And so if you notice, if you multiplied your x's together, you have x squared and x to the 3rd. And remember, x to the 3rd should have end behavior in different directions. And so that's what the sketch of my curve looks like. So go ahead and try the last 3, and that will be it for today.